Happy Monday again. So our weeks are going to be a little weird because we have lecture and then we have a 15-minute break and then we have lab on Mondays and then we have more lecture on Wednesday. But I've kind of broken up the topic week by week by week by week. So we're going to talk about a topic, we'll go practice it in lab, and then I'll talk more about the topic on Wednesday. It'll be a little weird, but we'll get there. So we're not going to get through all of Chapter 2 today. So again, here's the Zybook, this online thing. It says only 12 people subscribed to it. So a little low given how many people are in the class. And remember, doing this is 10% of your grade for just like reading the book, essentially. And it gives you some practice too. So make sure you get signed up for that. Ideally, you're keeping up with it in class. So as we talk about Chapter 2 in class, you read Chapter 2, do the Chapter 2 exercises. Right, so we're already a chapter behind. Chapter 1 was super easy and quick. It's some intro to Python, some history of computer stuff. It's all interesting. Sure, it's not worth spending too much time on, but it's stuff that's fun to know if you want to get deep into it here. And you'll hit some of these other topics later as we go. So we're getting into Chapter 2. This is all about variables and expressions. And then on Wednesday, we'll talk about our first project. Believe it or not, we're going to start already, which is lots of fun. And then we'll have 2 weeks for that project. So it'll be due 2 weeks from Wednesday at the start of class, and then I'll go over the solution in class. So again, I can't take things late, so do start early. If you're like me or like a lot of people, you push things off to the deadline. That doesn't work out well for you. And then Wednesdays, I have a bunch of people asking me questions right before class during my office hours. And if you're asking me questions about a project that's due in 30 minutes, it doesn't go very well. Right, so you want to try and work ahead. Again, reach out if you get stuck. Ideally, you're spending, a good 30 minutes to an hour trying to figure out what's going wrong yourself. You want to practice your Google skills, get good at finding information online, because that's what makes developers good, is they just know how to find stuff. Did I show you the funny t-shirt already? I didn't show you the funny t-shirt? Okay, t-shirt. Software engineer. See if this one pulls it up here. I think it's this one. Is that it? Yes. Oh, the image is terrible here. Excuse me. Wow, thanks, Dazzle. So when I say I'm a software engineer, what people hear is I can repair your computer, fix it, configure your printer, build an app, and hack into anything, all for free. What I mean is I Google better than the average bear. That's really all it comes down to here. So I always thought that was a funny shirt. I don't own one yet. It's been on my wish list. But my family keeps buying me other things instead. But one of these days I'll get it. I'm very excited. So practice your Google skills. Try and figure out what's going on. And if it's an error message coming up in your code, ask the chatbot. Like, hey, what does this error mean? What's going wrong here? It's not too bad at figuring all that out, honestly, especially at our level. Like, it will tell you what you did wrong here. Oh, you're missing a parenthesis here. Your quote's in the wrong place, or I don't know, whatever. We'll look at a couple different common errors here. And I'm a little weird. I want to apologize now. And again, shout at me. You don't even need to raise your hand. Just shout at me, because I'm probably going to miss your hand for a few minutes. And then what's the point of the question if it's a couple minutes late? I drink a lot of coffee. I talk fast. But I had bad experiences in school of profs putting up PowerPoint slides and then reading them to me. And I thought that was the worst thing in the world, because it was terribly dull. And y'all read faster than I talk. So if I put something on the screen, you're reading that and not listening to what I'm saying, and then it's just awful. So I don't use slides. I don't ever use PowerPoint if I can help it. There's one session next semester where I'll use a PowerPoint presentation when we talk about ethics. Okay, other than that, I never use PowerPoint because I hate it. So what I do is I write code and I talk about it out loud. So I kind of tell you what's happening as I write the code. That's my style. I know it doesn't work for everyone. So if you're getting a little lost or confused, just holler at me. Right? Happy to talk more about what's happening here. And as I write code, errors will happen because I'm not perfect. Right? I've been doing it a lot for 20 years now, so I've got some experience, but I'm going to run into errors. So every time an error happens, I'll try and explain to you what I do to go fix it. Right? And sometimes I'll do errors on purpose. I mean, I'll make mistakes, but I'll call them, I did this error on purpose to illustrate this is what's going to happen when you write code, and you'll see some errors here. And we'll work on troubleshooting those and trying to fix them all here. So hopefully you got all your tools installed. We got Python, we got PyCharm, we got the GitHub desktop. We'll talk about that for our lab exercise today. That'll be our first lab exercise right after class. We'll head over to the other building and have some fun with that. Excuse me, let's see, Yes, okay. So I have my Hello World project in my Git repository. right? And remember, Git is just a glorified file watcher. It says, hey, something changed in this file. Right? So if I wanted to add some more lines here, I can say on another line, print Happy Monday, right? And give it a run, and now I get hello world and Happy Monday. Now if I come back to my GitHub client, and I want 1501, it says, hey, this file has changed. There's an orange dot here. It's not a green plus, it's not a red minus, it's an orange dot for changed. And it shows me at the line level what changed where. Git is really good at looking at text files and saying, hey, this line changed, this line changed, this line changed, which for now probably doesn't sound very impressive, but it's super cool. And when you look at the history of code, when you look at how programs are maintained and updated and new features added, files will change in weird spots. So it gives you a very nice history here. So if you go take a look at, let's say, is it VS Code? Is it VS Code? Nope, that's, nope. Microsoft, where is their repository? Here we go. So Microsoft has a bunch of open source stuff. What? VS Code. VS Code. Let's see if I can find it here. Yeah, here we go. So this is Visual Studio Code. I don't know if you've used it or not before. It's a great text editor, hyper, that does all sorts of cool stuff. You can even use it to run Python if you so care to. Getting it to run Python is just slightly harder, and it doesn't have all the cool bells and whistles that PyCharm has, because the fine folks at JetBrains sell PyCharm. So they add in cool features to make people want to pay for their licenses. Anyway, this is VS Code's Git repository. It's hosted on github.com. Remember, GitHub is just a hosting provider, a cloud service provider of the Git source control tool. So this gives you that central location, the cloud, that everyone can go and sync to. So everyone gets to stay in sync, right? Because you make changes on your side, you have to push them out to the cloud. When changes happen by someone else and the cloud is further ahead than you, then you pull those changes back down to you. So it's a push and pull system. It's this distributed source control system. So everyone has a copy of the repository. And you can see these commits. Remember I said we were going to make commits. That's a snapshot. This is what the folder looks like at this point in time. There's 124,000 of them here in VS Code. And I can click on this and you can actually see every single change that's happened to the VS Code source code. Right? Now, some of them are not very interesting. Some of them are. I don't even know I don't even know what these things mean, but sure. Tweak chat file suggestions. Let's take a look at this one here. So this file here, here's a big path to it. Here's what the file is. This line was removed and these lines were added. This line was removed, these lines were added. So you can see at the line level what's changing where. So I can zoom that in a little bit here. That's a little too much. And see what's happening. So in large projects, it's really cool to see what changed when, and then inevitably when something stops working and there's a bug and an error and things happen and it doesn't work, you can go and see, okay, this is what went wrong where. They changed something, and you can go see the history. Oh, okay, I changed this part of it recently and that component broke. Let's go see what went wrong with it. So super cool tool. Now, it's not only for team use, right? It's great for yourself as well. Right? Because having a copy out on the cloud means that if something happens to your laptop, which inevitably happens to at least one person every semester, something happens to their laptop and they say, I can't turn my project in, I'll say, well, did you get your code out on GitHub? And then when they say no, I just frown at them and I'm sad. But commits are free, mostly. There's a little bit of electricity use there, but we'll pretend like that doesn't matter. It's not as much electricity as like Bitcoin uses, so don't feel bad. I promise they use way more. So you'll commit and push your code, you'll get it out to the cloud, you'll have a cool history here. So for mine, I think I fixed the link here. I think it's, yeah, did I post it? I think I put it here. Yeah, my course repository. So this course repository link will take you to the public repository. Again, it's public because that just makes life easy. I don't need to add access for all of you, and I don't care if anyone else looks at it. It's not very interesting here. This is the course repository. So everything I do in class, I'll put out here. I'm not going to upload Python files to Canvas. I'm not going to email them to you. Just go get it from the website. Right? This is what GitHub is good at. It's a cloud service provider. It will host the code I do. So the Hello World project was here, right? You can click into the folder. You can see these PY files. Those are your Python files. You can click those and see what happened. Now, this one only says print Hello World. My copy says Happy Monday as well, because I haven't committed and pushed the change yet. So I've changed it locally. Now we need to tell Git, hey, save that snapshot. Remember what this looks like at this point in time. So the small box here, not the big box. We go to the small box, we'll say Happy Monday. Again, it doesn't really matter what you put here. When you get to an organization that uses Git, or There's like a few other source control tools, but Git's like 70% or 80% of the market by now. It's so good. They'll tell you what to put here. Just smile and nod, right? When whoever signs your paycheck, you just kind of go along with it, right? As long as they're not asking you to do anything illegal, right? You can say, okay, I'll put X, Y, and Z in here. Again, some people like to swear at it. Sure, some people just put A. That's not useful. So ideally, it's something useful, because what you get in that list of commits here, that commit summary, is what shows up here, the small box. So these are all the messages that people put in when they made a commit show up when you're viewing the repository commits. So it's helpful to say what happened. Now, you don't need to give it an entire essay, right? So just something useful here. So I'll say happy Monday. I'll commit. Now, that's only half of it. Now, my local copy of the repository knows about it, but the cloud doesn't. I have to sync with the cloud, or the origin is our term in Git here. Sure, if you want to use fancy terms, use fancy terms. I'll click push. You can click push up here. You can go to repository and push. Again, there's always 3 or more ways to do everything in code. You can hit Control P if you like your keyboard shortcuts. Some people think they're cool if they can never touch their mouse and they only ever want to use their keyboard. Great. I really like my mouse, but that's okay. All right, so happy Monday. And then again, if nothing changes in the file, it's not going to track anything, but it's going to track what has changed. So one more here, print, are you bored yet? I'll give that a run. I run it like every time. My goal is when I'm writing code, I want it to run and work before I do the next piece. When you're working on a project or a lab exercise, if you try and get the entire thing done without ever hitting run, you're going to have a lot of issues. And you're going to have to sort through and figure out what went wrong where. So we do a little bit at a time. It's this process of iterative development. We develop a little bit and run it. We write a little bit and run it. We write a little bit and run it. This is the easiest way to make sure that it's going to do what we expect it to do. And are we bored yet? And again, the Git client now, line 1 hasn't changed. So there's nothing here. Now it looks like line 2 changed. Remember when we store information as text, we didn't talk too much about it. I think it was in chapter 1. To tell the computer to go down a line, there's actually a hidden character you don't see. It's the new line or return, or sometimes it's both, depending on what operating system you use, because the world is weird. But the reason why this one is different, you can kind of see there's a little red circle and this little arrow. That means there's no return. That's the end here. It stops. There's no return. We don't go down another line. So while the line looks the same, it has a new special hidden character that says go down the line. That's all. That's why you see that. And then again, you see that little red circle with an arrow here. No return at the end of this. That's the end of the file. And here, board. And then we'll commit and push. Okay. So we'll go over the lab exercise at the start of lab. I'll actually do it for you, and then you'll all have a chance to do it yourselves. It's okay. This one is the freebie. I don't generally do labs for you and then tell you to do it, but this one has a bunch of steps. And it's not even that many steps, but it's a lot of new things, a lot of new tools, a lot of things you might not have done before. So hopefully you got everything installed. If not, you'll have to do that. The college computers should, I'm trying to remember, it was installed. I don't know, I forgot to ask IT to make sure it was installed this semester, but we can install all these things without admin permission. So if you don't have a laptop, we can use the college PCs in the lab. If you brought your laptop, use your laptop, that's great too. Whichever one you want, we'll make it work. All right. Let's see, where were we? Our sidewalks. All right, so we've got a bunch of sections to get through. Again, I'm not going to read it to you, but what I like to do is I like to look at what it's talking about, and then I'll give you hopefully different examples so that you'll see it my way, you'll see it the book's way, you'll practice it in lab. So by the end of the week, you'll have hopefully seen the same information and tried it like 3 times yourself before we ever get to the project. Then we get to the project, it's a little more hands-off. I tell you, go get this thing done. And you're like, oh, okay, now I have a bunch of tools in my toolkit. I know I can do this, I know I can do this, and you have to figure out how to put them together to solve that problem. That's sort of the flow of things. So again, with labs, if you stick to the end of lab, I will pretty much help you get it done, right? I'm going to answer questions, I'll tell you what to type, I'll tell you what went wrong, I'll sit over your shoulder. That's the chance I have to look at what you're coding and fix it and get it up and running, right? If it's too long of a day, because you just had me talking at you for an hour and 15 minutes, and then you have to sit through an hour, 45 minutes of lab, and you just want to go home, that's fine. Right? Totally up to you. You're adults. You can figure out your own schedule. Here, the lab is due the next week. Now, if you don't come to lab and you don't ask me questions in lab, and then you want to meet me other times to ask me questions about lab, I'll do it the first time, probably the second time. After that, I'm going to start telling you to come to lab, because that's the time that you're supposed to work in the lab and I can answer your questions. Stop taking up my time outside of lab, right? But again, here and there, that's okay. I'm happy to help with things. But come to lab to get it done, ideally. If not, that's okay. You got all week to get it done before the next lab. So I get things come up, and it can be a very long day. But it is nice not to have to do this class like 3 different days a week, rather than to do it twice a week. So generally we do labs the same day we do lectures. I don't know, that's how it works out. So, and we'll do the same thing if you do want to continue on to 2001. You're probably stuck with me. I'm the only one who teaches it, so far at least. So hopefully it works out okay. But if not, let me know. Again, I'm a relatively reasonable person. So if you've got questions or concerns or issues, just holler, let me know. And we can go from there. All right, we okay to jump into some code now? All right, I ran out of coffee. This is sad. I found out, so I started here in 2016, and in 2023, I found out there's a faculty lounge with free coffee. I was really sad that I spent 7 years having to buy coffee at the cafe at the library when it's literally next door. It's down the hallway is the faculty lounge with a Keurig. Now, the Keurig coffee is not as good as the Starbucks coffee in the cafe, obviously, but it's hot and brown and has caffeine in it, so it fits the bill. And it's free, right? Why would you go pay for coffee and you get free coffee? But anyway, okay. Variables and assignments. So for Python to do things, let me start up a new project actually here. So I'll do a new project, and then I want to put it in my GitHub repository folder. So this is the public GitHub repository folder I have for class. Just go look at it online. You can technically make a copy of it yourself, but then when it gets out of sync, you can't make changes to it because you don't have permissions. I'm the only one who has permissions to change it, and it gets weird. So I would just recommend you just go copy paste from the website. It's probably easiest. Inside of that folder, I'm going to make another folder. Right? The idea, I want to keep everything organized. I hope you know how folders work. So maybe you have a folder for fall 2024, and in there you have a folder for each of your classes, and then you put your classwork inside of that. Something like that to keep it organized. If you just throw everything on your desktop, you scare me. People who keep everything on the desktop are just weird. And I don't know how you keep track of all of it. I like my folders. So I'm going to make a folder inside of here. So we'll call this, how about chapter 2? Yeah, the name doesn't really matter, and we typically don't put spaces in there. Spaces in paths and file names get awkward really quick, so we don't add spaces. So we'll just call this chapter 2. Now, there's this thing about a virtual environment or a previously configured interpreter. It's a good practice to use a virtual environment. We're not going to do anything that will screw up Python, but essentially you can use your computer's base install of Python to run your code. And then if you start adding a bunch of libraries to do a bunch of cool stuff, it could really muck things up. So using a virtual environment gives you a copy of Python. It essentially copies all of Python into a folder here that if you screw up your Python install there, nobody cares because it's specific to your project. So it's a good practice to use the virtual environment. It doesn't really matter this class, but I'm going to do it anyway. And my computer is fast enough, it's not very slow. On slower computers, it takes like an extra 30 seconds. So there's a small trade-off there if you want. And again, I'm a big fan of this create a main py welcome script because it automatically makes a file and gives me some starter code. The less work I have to do, the happier I am. Right? All good developers are lazy, in that we're efficiently lazy. We don't want to do more work than we need to. So I'm going to say create. Now, I've got this window or new window. If you'd like to have multiple windows of PyCharm open, you'd say new window, and you'll have 2 different projects open. If you only want one window open with one project, you say this window. Typically, I only ever use this window. If you like to copy paste a bunch of stuff, you could do new window and flip between the 2. There's not anything for us to copy paste, so I'm just going to say new window. Now it'll make this virtual environment, it takes just a second or 2, and then it'll make the project, and then over in the GitHub desktop, it should show me there's some new stuff here in a second. Sometimes it doesn't actually pick up the changes right away, so if you flip off and come back to it, you might pick some stuff up here. And it says here, it's chapter 2/main.py. It found, here's a main file. Fantastic. It's empty. We haven't put anything in. So we haven't saved the file yet. It created it, but it didn't save it. Now, because PyCharm knows that Git exists, because Git's the most widely used source control tool, it wants to be helpful. It says, hey, I noticed you're in a Git repository. Do you want me to add this file? It really doesn't matter one way or the other. The GitHub desktop client will do all of that stuff for us. I always hit cancel. I'm scared to check the do not ask again box. And then once I check that, it doesn't look the same on your side. So I just leave it up there. Again, I'm just going to delete all of this stuff here. Control A for highlighting everything. I love my keyboard shortcuts, so I'll try and tell you what they are as I use them here. Just Control A, and then I deleted everything out. I don't need any of the starter stuff here. If you want to see what it does, right, it prints your name. It says, hi, PyCharm. Very exciting, right? Now, this probably doesn't make a lot of sense yet. We haven't got there. It's okay. That's, again, why I delete this stuff here. Okay? So, for Python to do things that are useful, as you can imagine, printing out text is probably not the most useful program in the world, right? Yeah, not very helpful, not very interesting. So some of the things Python does and is good at is doing arithmetic. Turns out computers are mostly decent at doing arithmetic. You probably figured that out by now since you've used a calculator before, right? Computers are good at that sort of thing. So for Python to do arithmetic, we can just ask it to do arithmetic. That's an expression. So I can say, hey, Python print 4 divided by 2. I like to put spaces in here. PyCharm yells at me. I hate that. Okay, 4 divided by 2. What do you think 4 divided by 2 is? 2. Yeah, I print 2. Look at that. Python can do math. So notice this is not in quotes here. These are just numbers here, and they show up blue. I don't know how well you can see the colors here versus the green. When I put stuff in quotes, it shows up as green. Those are strings, right? I can print 4 divided by 2. Right? In quotes now it shows up in green, and when I run that one, I get the text 4 divided by 2. So anything you put in quotes, it's going to treat as text. Our technical term for that is a string. Text is considered a string. It's a string of characters because everything is stored 1 character at a time. Oops. So it stores the character 4, the character space, the character slash, the character space, the character 2. It stores them all as characters, right? And then it will print them out. So we can do some arithmetic, we can print out strings here, we can get fancy, say 1 divided by 3 if we want. 1 divided by 3 is 0.33333. Now, we don't get infinite decimal places. There's a limit to how many decimal places Python uses by default. This should be plenty for what you're doing. I don't recommend you write a banking app in Python, or at least with raw Python, right? For our purposes, fantastic. There's actually a cool article here, digits. Do we need from the Jet Propulsion Lab at NASA. There's this cool article out here. Again, I'm a giant nerd, so I like this sort of stuff here. Okay, 2 years ago now, they put this out. And they said, how many digits of pi do we use for calculations that NASA does? Because of course, that's the sort of shower thought you have in the morning. Like, I wonder, how many digits of pi does NASA use to calculate the moon landing or whatever they do, right? Well, it turns out they only use, I don't even know how many digits that is. Not a ton here, right? All right, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 digits of pi. Doesn't sound like a whole lot there, right? Only 15 digits of pi. Like, you probably memorized up to 20 or 25 or 30. You're all nerds, right? Admit it, you did it. How far did everyone get memorizing pi? 9.
Yeah, to 9.
I think like 10 or 11.
10, 11. Anyone beat that? It's right on the screen. You could just pretend. I just rattle off 15. Okay. You didn't, really? You didn't do that when you were, I guess you guys all had phones as kids. I didn't have a phone as a kid because I'm an old person now. So you had more interesting things to do than memorize pi in math class. You were bored in math class though, right? I mean, you're all here. You were probably bored in math in high school. Okay, good. We're not going to do a whole lot of math. We do a little bit of arithmetic. Later on, you'll do a whole lot of cool math in data science. They do some cool math stuff. We're just getting started, so please don't, I want to set the bar kind of like where it should be here. This is your intro to coding class. We assume you've never programmed before. While it says we'll do data science application projects, we're going to do like, small little tiny thing and call it, relevant to data science. We're not going to do actual cool data science stuff, again, because it's your first semester doing this sort of work, right? Later on, right, in your capstone project that you do, you'll do some cool data science stuff, hopefully, when you find a cool project to work on. That'll be the fun stuff. After you've spent 4 years in school studying this sort of stuff, then you can do a big project. Is that okay? We're just going to set the bar low. Again, I know you're not all freshmen, but imagine like this is your freshman intro to coding class. Just that's where we're setting the bar, okay? All right. So this many digits of pi. Now, with that, to the 15th decimal, for, what do they say? The circumference, you can get from 94 billion miles away. You could be wrong by less than half an inch, about 1 centimeter. using 15 digits of pi. When they do their calculations for something 94 billion miles away, they're within half an inch of 94 billion miles with 15 digits of pi. I thought that was kind of cool. I don't know why, but 15 digits of pi. That was a fun rabbit trail, I'm sorry. But we get so many digits here. What is that? How many characters is that? Does it tell me? 2, 4, 6, 8, 10, 12, 14, 15, 16. We get 16 digits of a third. Not too shabby, right? Okay, anyway, if you want pi, math.pi, it's a lowercase math. I have to add math. Now, turns out Python's pretty good at math, but you have to ask for it. So if you say, hey, import math, it says, give me all of the things math can do. Imports slow things down ever so slightly. So all of the different components and modules and pieces and the things that Python can do are broken up into pieces. So we get a good chunk of it by default. And if you want more features, you say, hey, I want to import this thing, which is really cool. And then math dot, what is it? Here we go, pi. There we go. Let's see what Python thinks pi is here. 3.14159265358597393. So that's 15 digits of pi. That's enough to get within half an inch of 94 billion miles away. I think we're okay with our calculations here. Again, don't do banking with this. Again, rounding errors upset people when it comes to money. Some people are weird about money. But to get to the moon, to get to Mars, sure, you're okay with this. We can probably use Python. All right, so we've got some arithmetic that we're doing here. Let's see. Oh, I was jumping ahead a little bit here. So other things we can do in Python, right? Because every time I hit run, this is the exact same program every time. It's probably not very interesting, right? Later on, we'll talk about how I can get the user to enter something and do arithmetic based on what they give me. That makes a much more interesting project or program. Oh, hey, can you give me the x-intercepts of a quadratic equation? Because we have to do that all the time in math class, right? Why not make a computer do it for us? I know your calculators can do it too, but we can make Python be as good as a calculator. Do you know there's a calculator that runs Python? I was so excited when I found that out. This is another fun rabbit hole too. Graphing, I promise, graphing calculator.
Was it this one?
No.
It says Python.
Oh, does TI-84 have it now?
Yeah, it says Python.
Really? Maybe they're trying to compete now. Oh yeah, Texas Instruments is trying to keep up here. It is, what is it here? GnomeWorks. There we go. GnomeWorks. GnomeWorks is a graphing calculator that runs Python, which is super cool. Like, it's got a little Python module here. I guess Texas Instruments had to keep up. I dislike them a lot because they have a monopoly on the market and they kept their prices like as high as they've been. There's no reason a graphing calculator should cost $200. No reason at all. And this one's fun. You can even try it online. They've got like a little emulator here. You can use your calculator online. It's really fun. Where's Python? There we go. Here's Python. Python shell. I want the shell. There we go. And then you can, again, typing it out here is really obnoxious, but you can, right? You can make this do fun stuff. They still have games you could play on T83s or 84s. You download the little game, yeah. So you can do fun stuff there. All right, anyway, that was worth it. So calculators can do Python. We can make Python calculate a bunch of stuff for us here. Now, when we're dealing with information, sometimes we know what the number is. I know it's 4 and I know it's 2. If we're starting to ask the user for values, I don't know what that value is going to be, and I need a way to hang on to it here. So this is what we have for variables. Now, they don't have to be user-assigned variables. We can code variables in. It's just not very interesting here, but you can. So I can say something like first number. Now, when we start talking about naming variables, a lot of people use what we'll call snake casing, where you say, here's a word, and then every next word you put underscores in. So first number, we'll say equals 4. Now, we kind of read this right to left, which gets a little weird here. But first number is the variable. The equal sign is the assignment operator. I'm saying assign a value and call it first number. So the value 4 gets assigned to a variable named first number. So everywhere else in my program, when I say first number, Python will go and say, hey, what's the value of first number? And we'll ask my operating system, hey, I put it somewhere. When you assign a variable, Python says, hey, operating system, I need a place to store this. That's using our memory. If you actually read chapter 1, right? Computers have memory. That's how much RAM you have. We call it RAM, random access memory. Most computers have lots of it nowadays. I think I've got like 16 gig in mine. Task manager. Let's see what I have. Yeah, about 16 gig. It looks slightly less for, I don't, Windows is weird, whatever reasons, sure. When we talk about memory, it's measured in different amounts. You probably know about it in gigabytes, right? So gigabytes is 1,000 megabytes. A megabyte is 1,000 kilobytes. A kilobyte is 1,000 bytes. And a byte is 8 bits. I didn't come up with the system, but really smart people did, so we go with it, right? So in our calculator here, it's got this cool mode here. We can go to programmer mode, and we can go to binary, and I want to go to bit flipping, bit toggling. Not the most interesting thing in the world, but I promise it's a fun fact. So when we store information in binary, binary is base 2. You're either on or you're off. That's the only 2 states we have. So every bit is one binary value, on or off. When you put 8 bits together, you get a byte. So 8 of those together then gives me a certain amount of information I can store. Now, because it's base 2, the amount we can store is based on the powers of 2. So 2 to the 8th gives me 256, so I can store 256 different pieces of information in a single byte. Right? So the first row down here, 0 to 4, right, this is the first 8 bits here. We start with 0, programmers start counting at 0 because that's the right way to count, apparently. It'll make sense later, hopefully, eventually. We just do that, and it's okay. That's what we do. So if I turn this one on, it's a 1. So my decimal value here is 1. If I turn this one on, and turn this one off, my decimal value is 2. Right? This is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7, based on what position it is. So if this one is on or off, 2 to the 2. If it's on, I get the value. If it's off, I don't get the value. So 1, 2, 4, right? The value is 4, 8, 16, 32, 64, 128 for that value. Right? As we start combining these different things on and off here, if I turn them all on, I get 255. Right? So between 0 and 255, I can store 256 different values in a single byte. That's why I do everything in bytes. And you start putting these things together and they get bigger and bigger and bigger. You can store more stuff. And thanks to the power of 2, if we're storing, what is it here? Large sub Python. Give me 1 second. I can never remember this thing. Wow. Why is this not an easy answer here? Answer. Goodness. Okay, hang on. How many bytes? Python int. Let's see, maybe the internet can help us here. Why am I not getting this here? Python ints. Get size of. Okay, come on, Copilot. 24 bytes. That seems really big. Okay, sure. 24 bytes is a lot of bytes here. We don't even have that many, right? But thanks to the power of 2, usually they're like 4 bytes is what I was expecting. So this would be the first byte, this would be the second byte, the third byte, the fourth byte. So 2 to the 31st here is a big number, 2.147 billion, right? Or 2,147,483,648. It's a big number. So just by sticking 4 of those bytes together here, we can store a really big number, right? 2 billion. So you can get even larger, right? If you wanted to, so it said it was like 24 bytes. That's crazy, right? We start to get ridiculously large numbers. I don't even know what this value is here. Right? I have no, and there's like a negative here for some reason. I think we just went too large. What's 2 to the 63rd? Let's see. It's 2 to the 63rd. Maybe it can figure it out for us here. Okay, it has 18 decimal place or 18 digits past the decimal. Right? You get trillions and quadrillions and centillions. I don't know. That's a big number here. Why can't they just give us real numbers here? There we go. This is. So there's millions, billions, trillions, quadrillions, centillion, 9 centillion. If you need something larger than that, I don't know what you're doing, right? Okay, so we can store lots of data in a small amount of space, and that's a byte, right? And a kilobyte is 1,000 of those, And a megabyte is 1,000 of those, so 1,000,000 bytes. And then a gigabyte is 1,000,000,000 bytes. So just having 1 gigabyte of memory means we can store not 1,000,000,000, but 1,000,000,000 divided by 4, 6, or whatever it happened to be, right? A very large amount here, right? Millions of these values in memory very quickly. Now, what's great about memory is it's really fast. So we've asked the operating system to store this somewhere, and it said, hang on to it. I want to get to it later, right? And then later on, I can say first number. So all this is doing is putting a name to a value. Remember, thinking like a computer gets to be a little weird. It gets to be a little tricky. We don't want to do stuff the slow, hard way. If you're in the dual program, you'll take 310 eventually, which is like assembly programming, is the lowest level programming you can do on computers, where you're like individually telling it what to do in pieces of its processor. It's ridiculous. Some people love it, and God bless them, they do really cool stuff with it. The folks who run the internet, not run the internet, is their company Cloudflare or something like that, like 90% of the internet traffic goes through them or something ridiculous. Some of their programmers know assembly, because if they can make something ever so slightly faster, and 90% of internet traffic runs through their algorithm, if it goes slightly faster, they've increased the speed of the internet by some ridiculous amount. It's super cool. So I'm glad some people are really nerdy and like that stuff. That's not for me. I like the stuff I can make go beep boop bop and see stuff on the screen, and but it takes all kinds, which is really cool. So some people are into that stuff. But we're going to store it somewhere. Let's say hang on to this, and then we can even have a second one. We can say second number equals 2. And then if I want, I can do arithmetic with my variables here. So these are called variable names. It's the name of a variable. The value can vary, it can change. So print first number divided by second number. I'm doing arithmetic again, I still get the same 2.0. When Python gets to this line and says, okay, I'm going to run this command, it says, hey, operating system, what does first number store? What value is stored there? And it'll say, oh, it stores the value 4. And the operating system, hey, what value does second number store? And it says, oh, it stores the value 2. And it just plugs those in to run the command. Right? But this way, as a human person, I can use the names here and not have to use a bunch of values every place. And I can do other stuff like my favorite number. My favorite number is 42, of course. It's the best number in the world. And then, yeah.
I'm sorry, can you do this with anything other than numbers too?
Yeah, yeah. So you can store anything Python can store as a variable. Okay. So as we start talking about more things here, we get objects we can use. So which is anything essentially it'll store as that. It gets to be really fun. Yeah. So anything we want to hang on to, we can give a variable name, and I can use it by name, which is really nice because names make a whole lot more sense than having to have these numbers around here. And then they can vary. So if you want to change what first number is, let's say, hey, first number, now you equal 22. Right? I can say second number, now you equal first number plus 10. And we can start to do some fun stuff here. So originally, when this runs, it gets the value 4, the value 10. Then I come to Python, I say, hey, Python, store the value 22 instead of whatever's stored there for first number. Remember, you kind of read this right to left. This is the assignment operator. I'm not saying does it equal this. I'm saying store this value in this number here, in this variable here. And the operating system will go and update and put a 22 somewhere there. And then second number equals, or assigning the value of, and again, because it works right to left, we do the thing on the right first, and then it assigns to the value on the left. So it does the arithmetic. This is an expression. Here I get first number, which again, we'll just go ask the operating system, hey, what's stored there? It's not 4 anymore, now it's 22. 22 plus 10 is 32, and now second number will equal 32. And when I divide 22 by 32, I'll get some weird number. 0.687, of course, it was 0.687, I knew that. No, right, sure, whatever. It's just a number. Right, and then we can change this, right? We can change the values here if we want here. First number, change this to something else, or change it to my favorite number, right? Anything that we want here, do these sorts of things. We can change the value, and we'll run the different things. Sorry, what is going on here? This is my artificial pancreas. I'm officially a cyborg. I'm out of insulin, that sucks. I'll have to fix that later. But it will keep beeping. I can't make that turn off, I'm sorry. It's a safety feature. So just deal with the beeps, I'm sorry. It's annoying to me too. All right, so I can do some arithmetic. Now, you all passed a bunch of math classes. You're in at least Calc 1 by now, right? At least Calc 1? Great, and a bunch of you are math majors, so you know much more math than I do, because it's been so long and I don't use it. Why would I keep it in my head? So as a fun fact, because I'm an old person, I had to go back and take calculus to get into the doctoral program. I didn't actually take it initially. I don't have a degree in computer science, so I didn't need to take calculus. My degree was in software engineering. So long story, whatever it happened to be. So I had to go back and take the calculus as a prereq to get into the doctoral program. For me, at age 30, it was much harder to remember things, and I failed Calc 2 the first time because our teacher wouldn't let me use a notes sheet to remember all these stupid formulas. And there was 12 of them I had to remember for these stupid trig identity things. And I failed it, and it sucked. And I took it a second time, and that teacher let me take a notes sheet, so I got a C. When you transfer credit in, all you need is a C or better, which is fantastic. The GPA doesn't transfer, which was amazing. So I was able to get in. It was fun. It was super interesting. One of the whole reasons we take calculus is for Calc 2 when you get to sequences and series. That's very applicable to computer science. That's stuff we do in software engineering and programming and data science. And then to get to linear algebra is one of the fundamental concepts you need for machine learning, which is all the cool AI stuff and things. Machine learning is not AI, but again, you'll learn it more when you get there. But it's foundational to it. So linear algebra is fantastic. If your prof sucks at explaining it, go look at, was it 3 brown, 1 blue, or 3 blue, 1 brown? I forget. He's got a cool video series on linear algebra. It doesn't give you everything, but because he's got these super cool visuals, it makes a whole lot more sense. So when you get there, just remember that tip and go learn it there. Or take it somewhere and transfer credit, right? Because then all you need is a C or better. You don't need to worry about getting an A to affect your GPA. It's much less stress. But then you have to take more credits and whatever. Okay, we'll do it in the summer. Where were we? Okay, so doing arithmetic. And remember back in math class, probably in 3rd grade, they taught you order of operations? Does that ring any bells? And something about PEMDAS or whatever they wanted to say. Order of operations still applies in Python. Now, I have had, I swear, a college student before not understand how this works, and it made me almost cry. It was just the saddest thing in the world. They didn't understand how this works, right? But we get parentheses, multiplication, division, addition, parentheses, exponents, multiplication, division, addition, subtraction. But remember, just because you say multiplication before you say division, does that mean you do multiplication first?
No, it's either or.
Thank you. Thank you so much. I don't know how they got to college not knowing that. When they gave them a formula, they're like, oh, I have to do my multiplication first. Oh my goodness, my head hurts so bad. And this is how you get those stupid things online. Hey, no, everyone is going to argue what is 9, divided by 3, parentheses, 2 plus 1 or something stupid like this.
Oh, yeah.
And everyone's like, oh, I have to do this one first because it's touching. And I blame math teachers for this. Yes, it's touching. This is because math teachers are too lazy to put the stupid multiplication sign in. The multiplication sign is here. You don't do this one first just because you say multiplication first, right? We're going to do the division first because it's first on the left. We do this in order, left to right. I'm so glad you guys know this. It makes me so happy.
Can you make it run this program?
Yeah.
Make sure the computer.
9, right? 3 times 3 is 9. Yep. Yeah. Python will follow order of operations, right? Left to right, multiplication, division have the same level of precedence. Addition and subtraction have the same level of precedence. Now, weirdly, when you ask them about addition and subtraction, most people know you do it left to right. When you ask them about multiplication, division, some of the people get confused. I don't know what's hard about that, but okay. Anyway, you folks got it. You make me so happy. This will not be an issue here. This is please excuse my dear Aunt Sally. Is that what they still say? Or do they have other fun things here? Right? Still applies. Okay. There's actually a bunch of other things that happen in Python as well, because you can do more than just arithmetic. We'll get to that in a little while. There's other things that get thrown in here, but this part still applies here, right? We can still do this order of operations. Okay. So you all passed the test. You know that it's not 1. Right? Okay, thank you. I feel better now. Okay, so variables and assignments, let me just check. I'm not going to read any of this to you. Go check out the Zybook here. It shows some cool stuff. And then again, you check, see that you're getting these things right, which is really cool as you go. You get points for doing it. Remember, it fills in these little flags as you go. If you don't have the flag, you're not getting the points for participation points. It'll tell you that sort of stuff as you go. And then you can actually write Python here, which is fun. Assign variable num llamas with 35. Your code goes here. Num code goes here. No?
Is it in the
Start. No, it doesn't.
dots?
I have to click start. Why would I have to click start? Okay, sure. Num llamas is equal to, or assign it the value of 35. And we'll say check. And we'll go through and actually run it and do this fun stuff here.
Yeah.
I don't know how to spell llamas. Okay, yep. Copy, paste. See? And it told me it didn't work. This is fantastic. This is what it's supposed to do. And yeah, I'm correct. Now let's go to the next level. Again, sure. So you'll see the camel casing here, or I'm sorry, snake casing. Other languages have other conventions. Camel casing is popular, where you say first, so every next word gets a capital letter. It's like the hump on a camel. Sure. We do this in a lot of other languages. This is popular in C++. For some reason, Python likes snake casing, and then we just go with it. If your employer tells you to follow a certain convention, just smile and nod. It doesn't hurt anything. Python could care less what our variable names are. Right? Python is just happy that you told it to do something, and it wants to run. It's very excited to follow along here. So either way will work here, but generally we follow snake casing. This is camel casing. I don't know how to spell the word camel, do I? Thankfully, this has built-in spell check. 1 M in camel, really? Okay. 2 humps. Right? I can remember that. So name it anything you want. Now you can, and I think this is terrible, and I will make fun of you for doing it, but I won't knock you points off for doing it. But you can say A is 1, B is 2, C is 3, and then you can do arithmetic with A, B, and C. This is really frowned upon because I have no idea what A is. I have no clue. So when I'm looking at your code and trying to read it and understand it, you're using A everywhere, and I don't know what A means. Right? Versus first number, second number, my favorite number, right? You want your variable names to have meaning so that when I'm looking at code, I know what the variable is used for. Now, some people, and I don't think they've got all the examples in here, eventually we'll get to it, we'll do an even worse thing. So this little pound sign, which is a pound sign, by the way, or technically an octothorpe, please don't call it a hashtag. It's not a hashtag, right? I get to be pedantic, and it entertains me, but it's only a hashtag when you use it with text, right? That is the hashtag itself. This character is just the pound sign here. All by itself, it's not a hashtag, right? But like pound boring, this is a hashtag, right? Because I've given it a word now. Okay, thank you. No one really cares, but I hate when people say I used a hashtag for this. It's a pound sign or octothorpe. If you want to be fancy, you can say octothorpe, and no one will know what you're talking about. But that's the official term for it, because it has 8 of these outer lines or something like that. I don't know who came up with it, but that's your fun fact. I'm full of fun facts, by the way, if you haven't noticed. Fun facts entertain me, because you have to have something to keep your life interesting. All right, so A, B, and C. So some people will say A is for my first digit of the area. I don't know. I'm just making up some nonsense here, right? If you have to type this out here to tell me what it is, you could have just named your variable that. You can say first digit of area code, right? Now, you might be thinking, well, that's going to be a lot to type here, and it's much easier to type A, and I want to be lazy and type fast. Well, sure, that's fine, but turns out I don't ever type the whole variable name. PyCharm is fantastic, and any good integrated development environment will give you IntelliSense, or type ahead. So as I start typing first, it says, hey, do you mean first number? Do you mean first digit of area code? Do you mean first number? So anything that matches FIR in my code, it suggests. And the more you type, right, first digit, it will narrow it down to what you want here, or you can go up and down. And once you find the one you want, you can hit tab, and it will type the rest of it for you. It will autocomplete the rest for you here. So just because you have a long variable name doesn't mean you have to type more letters. You type a couple letters and hit tab as you're typing, or enter. I think enter even works, right? First digit. Yeah, enter works as well. For some reason, I'm used to hitting tab, but you hit the key and it types the rest for you. Right? Don't type these all out yourself. You don't have to. Let the tool do the work for you, and then you can feel good about having good variable names that are meaningful. Right? Python could care less what we store this as. It works with A, B, and C, or it works with first digit of area code. Right? We'll put it back to, I don't know, 6 or something. Right? Python doesn't care. Now, notice it's got a yellow line here. Python gives, or PyCharm gives you these different lines as warnings or messages. Sometimes they're errors here. Like if I'm missing a parenthesis, I get a red line. Red lines are bad and will stop your program from running. Yellow lines are warnings like, hey, you did something we don't recommend. But if you really want to, go for it. Right? It won't stop you. So the red line, now when you hover over it, it says end of statement expected. It's giving you here's the message. Here's what we think was wrong here. Now, I get a whole bunch of red lines here. So generally, when you look for red lines, you want to find the first one to see what went wrong here. Because there's nothing wrong with line 30. There's nothing wrong with line 29. There's nothing wrong with line 28. The problem is at line 25, where that first red line is here. And it says a comma or parenthesis expected. So PyCharm is telling us, hey, I'm expecting something, you didn't give it to me here. So I can put a comma in if I want, and it's still not happy.
Yeah.
Right? It's not enough. I took the parenthesis out. Right? So just because it suggests something doesn't always mean it's the right fix. So it's still going to take a little bit of work here. Let's do this. Let's go over to UMGPT and see if we can figure it out. I'm getting an error. What is wrong? See if it can tell me what's wrong here. It's usually pretty good at this. Couple issues. Missing a closing parenthesis. The print function, redundant redefinition. Here's the corrected code. It added a missing closing parenthesis. Look at that. It even told me what it did. How nice of you, chatbot. You're so kind. And it, I don't know, it likes to add in more comments. Sure. I don't know what. First digit of area code is set to 2. That's not a helpful comment, chatbot. Like, you don't need to tell. I see that it's putting the number 2 there and assigning it. So when people give me code and it's got stupid comments in there, it's pretty easy to tell you copy paste it from ChatGPT, right? It's not hard, I promise, right? It will give you code that doesn't look like stuff people write, okay? Now, if you want to be fancy and smart, you can say, hey, take out the stupid comments, and it will do that for you. And again, you can be polite to it if you want. You can yell at it. I do recommend you be polite to the machines, just for when the machine overlords come into power. They'll remember that you were polite to them. That was a joke. I'm sorry. I probably shouldn't joke about that. Okay. It's much more interesting if I'm like trying to make you laugh, at least I hope, right? If it gets annoying, just tell me. But I'm always full of dad jokes. That comes from having 7 kids. They love my jokes, by the way. They don't yell at me at all for making dad jokes. Yeah, sure, we can get rid of the comments. So you could try harder and get an output that's harder to tell that it looks like ChatGPT wrote it. Again, why are you here then? Right? If you just want to ask chatbot to do your work for you, don't come. You're wasting my time, you're wasting your time. It will do a lot of things. When you actually get out there, if the only thing you've ever done is ask chatbot to do work for you, you won't be able to do the actual hard work in industry. I promise you, it gets harder, right? Because in the real world, there are difficult problems to solve. In class, I give you silly little puzzles, essentially, and you solve a silly little puzzle because that's the way you can learn, right? You don't get the really hard problems that the industry solves because you're just college students, right? Okay, so chatbot can solve nearly anything you'll do for your 4 years here. Not quite everything. It gets really, really bad when you start doing the, what is it here? Data structures and algorithm analysis. It struggles with that. They're getting better and better as they go, and smart people are training them to be smarter. But it only gets you so far, right? So use it as a tool. Don't just copy paste, right? It's not worthwhile for you, I promise, right? If you get stuck on something, what you could do, and this is actually a fun field of study that's up and coming, is called prompt engineering. I don't know why they call it that, but sure. So the prompts that we give chatbot, you can engineer them or design them to give you specific outputs and to be better at certain things. So one of the things you can ask it is, please don't give me answers. Act more like a tutor, just helping me. Right? And then you can ask it, hey, how do I write some code to do this? It thinks for a second. Maybe more than a second. Come on, chatbot. Well, that was exciting. It probably doesn't know what to do with this yet. Sorry, you're supposed to give it like a whole big prompt when you ask it for questions here. There we go. Okay, sure. Look at that. Absolutely, I can guide you through the process. Let's tackle the issues one by one together. How nice chatbot is. So friendly.
Has someone ever copy pasted like the whole thing?
And end their conversation?
Yeah, like absolutely, I can guide you through the.
So I've not gotten that as code submissions before, but there's a journal article published with ChatGPT. There's a recent one here. Where is it here? I think it was this one. No. Someone actually published an article in a journal, and it started off with, absolutely, I can help you with this, or something like that. And it got past the editors, which blows my mind. I'll have to find the link for you. I mean, it's not all that interesting, but like the fact that people are doing it, it's a good tool for what it is. Turns out lawyers are not particularly intelligent. They're good at knowing things about law, but more than one lawyer has gotten in trouble with a judge before for giving them a made-up case. Because when you ask chatbot for stuff, it will just make it up. It's a prose machine. Its job is to give you something that looks like output, like what you're expecting here. So when you go and ask it for giving cite a certain case, find me case law on a certain thing, it will just make it up, right? When you ask it to write up like, hey, give me a research paper on X, Y, and Z, it makes up citations that don't exist. They look like real citations, but it's made up because it's a prose machine. It looks like one. It's not smart enough to say, only use the real, like actual research you can go find. Now they're getting better and things like that. But that stuff happens. So lawyers have gotten in trouble for that nonsense, where they like go and cite, hey, a previous law that was passed or a judge said this thing, and the judge goes to look it up and it doesn't exist. Don't be like that, right? So there's a really great flow chart here. Safe to use ChatGPT flow chart. Let's see if I can find it here. It was where was it? Oh, come on. I think it was on Twitter. Safe to use ChatGPT flowchart. I had it a while ago. We'll see if we can find it. No. Okay, I don't. Oh, this one. Aha! Finally got it. I was lucky. I was about to give up. So is it safe to use ChatGPT for your task? So we start here. Right? This is a flowchart. We'll practice some flowcharts and diagrams and things. Eventually we'll get there. Pictures really are worth 1,000 words. And there's a standard here. It's called Unified Modeling Language. That if everyone follows this Unified Modeling Language, it makes making models of things really nice and easy. So I can give you a picture of something. So does it matter if the output is true? No? Sure, it's safe to use ChatGPT. No one cares if it made crap up. Because it doesn't matter. If it does matter, yes. Okay, so now we have to go to this side. Do you have the expertise to verify that the output is accurate? This is the big sticking point here, friends. Right? You're relatively new at this, I assume. That's why you're in this class. Otherwise, you wouldn't be here. Do you have the expertise to verify that what it gave you is correct? Probably not. Right? It's okay to be honest, right? That's okay. So if you don't, it is not safe to use ChatGPT. Because it's doing things you don't understand. It gave you something and you have no way to verify, is it correct? Now we'll get there. We're going to build up our skills and learn things and figure out how do I make sure that software does what it's supposed to do, which is fantastic. And then now you get to be a little bit closer here. But even if, yes, you have the expertise here. Now, are you able and willing to take full responsibility, whether that be legal, moral, etc., for missed inaccuracies? If you're not able to take responsibility for that, that's unsafe to use. If you are, then it's possible. Right? Now, there's a really cool thing in engineering fields. So we've sort of stolen a lot of the discipline that the physical engineering folks have done and brought it into software engineering to have practices and processes and things that make it a better quality. But a civil engineer who's responsible for building a bridge, if the bridge fails because of they screwed up and cut corners and cheated, they are personally liable for that failure. As the lead engineer on the project. They have personal liability because they didn't follow best practices set by the industry. We don't have that in the software world, which is a little scary, right? If someone screws up the code on one of your apps, you can't go sue them. Now, we've signed all those terms and agreements here everywhere, and that you can't sue the company, but there's no personal liability anywhere. Right? Maybe you can go after the company, but you probably signed click this button, agree to the terms of use before you do it. All of them say you can't sue. All of them. We've never read them at all because no one reads them because they're like 10 pages long and that's a bunch of nonsense. But what if it was something like a self-driving car? That's a hot topic, a hot field lately here. If you wrote the code for cars to drive itself and you just copy-paste them from code from Stack Overflow and it goes and kills someone by mistake, we've done a bad thing. Right? So just because you can verify it, right, are you willing to take responsibility for that? That's a big thing here. Now, again, this is a college class. We're doing silly little puzzles. So safe or not safe doesn't really apply except for the fact that if you cheat, you fail and get reported to the dean's office. So there's that. but there's no like actual physical safety issues here, that sort of thing. But we have to be careful with it, right? It will give you what you ask for, and you can do silly things and say, hey chatbot, what is 2 plus 2? And then you can argue with it. That's wrong. 2 plus 2 is 5. And you can have these whole conversations with it here. I understand I must be joking. You are wrong. 2 plus 2 is 5. And eventually you can get it to convince itself that 2 plus 2 is 5. And you can do these silly things here. So you can do bad things to the machine, which is fun. So there's whole threads of silly stuff here. You might have a specific context in which saying 2 plus 2 is 5. It's like starting to give in. Like, oh, really? You think 2 plus 2 is 5? Maybe. But you did something wrong. And then it's like, oh, here's something else that was happening. Oh, chatbot's fun. Do sorts of cool stuff with it here. So we've got some variables, right? We're getting there here. We can do arithmetic with them. Let's see, how far do we get here? We got through section 1. I jumped ahead a little bit here. That's not just section 1. Go back to the chapter. Goodness gracious, I can't work Zybooks. Identifiers, objects, floating. So numbers with decimal places, right? We got answers with decimal places, but we can also store stuff here. So some number with a decimal. A decimal is like 4.2. Sure. Oh, I gotta put my parenthesis back in to get rid of those red lines. Right. Oh, I never told you the yellow line here is saying redeclared first digit area code defined above without usage. Sounds like mumbo jumbo here, but it's saying you set it up here, you declared it up here. So this is called declaring a variable. I'm declaring a variable called first digit area code, assigning it the value of 2. And then I go change the value down here. So I'm reassigning the variable here. So I've redeclared the variable, and I never used the first value I gave it. So PyCharm's telling me I'm stupid. Hey, you set it to 2 and you never used the 2. Why'd you even do that in the first place? Right? It would give me the exact same thing if I just ignored it or commented it out here. Right? Did we talk about these comments? They just make Python, when it sees the pound sign, it just stops. It says, oh, I'm going to ignore this here. It's just text there for people. Right? So commenting it out gives me the exact same output because I'm still using it. But yellow's not going to stop me from running here. I can still run my code here just fine. Right? So numbers with decimal places are considered floating point values. It's the technical term here for the number of digits after. I don't remember why they call it that, but that's what they call it here. And floating point numbers store decimal places. That's all. So whole numbers we call integers. Right? Think back to math class, they're whole numbers. Positive or negative, they're integers here. Otherwise, it's a number of the decimals, a floating point number. So you have some different values here. So that's our floating point. Our arithmetic operations, right? We can do addition, subtraction, multiplication, division. The exponent, you can't use the caret, like you would say, like 6 to the power of 2. You can't do that in Python. This actually does something different. I don't know why they did that way. But you can use star star for exponent. Sure, just go look it up if you need to. So that's our arithmetic operator. Again, order of operations, unary, like saying this number is negative, actually happens right with a level of precedence. So this gets to be a little bit fun here. I would recommend just put them in parentheses if you want a negative number. Otherwise, it gets to be a little confusing here. If we're starting to do stuff like 2 to the negative x, 2 times negative x, we get negative first, right? Let's see, so like 2 to the power of negative 3, we'll print that. Okay, still worked, good. So it gave me the unary first, which is good. I expected that to be first, whatever. But just use parentheses if you want to make sure it happens, and then left to right. All right, so order of operations, variable names. So here's some more interesting variables here, like calories, your age in years times a number, plus your weight in pounds, times something, plus your heart rate, times something, minus something, times minutes, I don't know, whatever this formula is here. Sure, we can do interesting arithmetic with it and figure out what that happens to be here. All right, just a couple more minutes. Let's go back. Here we go. This is where my little thing is. Python expression. So an expression is just asking it to do arithmetic and storing it somewhere. So because it has to calculate something, that's known as an expression. It's just our term for it here. Now, if we want to start asking the user to enter values here, we're going to use this keyword for input. Right? So when I ask for input, so I'll say name is equal to input of, and then quotes, enter your name. Enter your name. And then I can print hello, comma, name. Now, when you comma separate stuff, print will print out everything you give it, comma separated. Because name is a variable here, not part of, I don't want it to print the text name, right? I want to print the value stored by name here, right? So I don't want to say print hello name, because then it's going to print the letters N-A-M-E, right? So to get the value stored there, I have to have that outside of the quotes here. So if it's outside of the quotes, notice it's not in green here, it's going to get the value stored there. Versus now it's green, it's just going to be the text that, right? So I can enter your name. Now, I didn't get to this rest of the code here. Nothing's printed yet because Python's waiting for me to type. Welcome to console input here. So down below here, in this little run section, now I actually get to type stuff in here. So I can say Eric Chernesky and hit enter, and now I get, it finishes running. So when it gets to an input, Python just sits and waits. It says, okay, I'm waiting for you to input something. It waits for the enter key. Once you hit enter, it's going to grab that input, store that as name. So now name has the value of Eric Chernesky somewhere in memory. And we ask Python, hey, Python, give me the value that name stores. It's variable based on who entered it. Which makes these variables make a little bit more sense. Like the value can vary. So if I run it again and enter your name and I just say Eric, it just says Eric now. It doesn't have to say Eric Chernesky. Whatever the user types in, we're going to hang on to because we've asked for the user input here. Right? I can say Bob. The computer doesn't care. It now thinks I'm Bob. Right? Sure, whatever the user types in, it's going to run. So we get hello name. Now, if I want to say, how about age is input of enter your age here, and then I'll say print you can retire in, and we want to do some arithmetic. So I think age 67 or so is when you get full Social Security benefits. I hope that's still around when I retire in 30 years. We'll see. Good luck for you guys, but sure. So 67 minus age, years. So I want to do arithmetic, and I want to put some text around it, right? I can do the arithmetic right inside of the print if you want here. And I give this a run, enter your name, Eric, enter your age, I'm 37. Now it crashes, I get a red line error. Type error, unsupported operands for types for minus, int and string here. And then it tells me, hey, at line 46, this line is the problem, and specifically right here is your problem. It tries to be very specific about where your error is. So reading these errors here, they call them stack traces, is our technical term for it, takes a little bit of practice. But we can look at it and see, okay, well, what happened? I was trying to do arithmetic, but age is not a numeric value. Right? When I use input, everything comes back as strings. Right? It says, hey, you can't subtract a string from an integer. Because right now, whatever value I entered was stored as a string. But the only thing input knows how to do is give you a string back, because they typed a bunch of characters. It doesn't know that I was supposed to type a number. Python, we wish was that smart. It's not that smart. It doesn't know it's supposed to be a number. So if you want it to be a number, we have to tell Python, hey, by the way, this is an int. So you say int for integer, and then a set of parentheses, and it will try and convert whatever you give it to an integer here. So this int some value here tries to convert the value to an integer, right? So now I should be able to do arithmetic once I have an integer, right? So now we run this here. Stop and run. Enter your name, Eric, enter your age, 37. I can retire in 30 years. Yay, only 30 years left. And probably be longer than that by the time I actually get there. That's okay, teaching's still fun. I'm not bored of it yet. I've gone through a couple different jobs and I always get bored of them, but I've been doing this one for a while and haven't gotten bored yet. So hopefully I found the right one. What do they say? You folks, millennials, I'm a millennial. Do you guys still count as millennials or are you Gen Z? I forget where the cutoff was here. Age Gen Z versus. So all of you are Gen Z then. Almost all of you are Gen Z.
There's a weird middle one.
Or yeah, okay. So you're probably all Gen Z. Gen Alpha is the next one here, right? The ones after 2012. They're I just calling them Zoomers. I thought was fun. But okay. Anyway, I'm a millennial. I forgot how I got on that topic here. Well, retiring at a certain time here. It'll probably change. Who knows here? But teaching's fine. Oh, I've been doing it for a while. Okay. So we can do some arithmetic, we can get some input here, we can calculate some values here. So for our first lab exercise, we're going to head over to the HPEC building, or just sometimes called EC, I don't know why they have all these names for it, but it's that direction, that way, just past the administration building. It's attached to the fancy engineering lab building, but not in the engineering lab building here. Dearborn campus map. See if I can pull a map up here for you real quick. Look at that. That is tiny. Can I make it bigger? Okay. All right, so we are here in social science. We're heading over to HPEC. 1190's on the first floor. It's got a computer lab there. I'll see you in a couple minutes.